All right, welcome. It's Thursday, August 6th. And today we're going to look at domain and ranges of a relation and or functions. Remember, a function is a type of relation. So it's going to be looking at a function, being able to identify what its domain is and what its range is, and then write that using a special notation called interval notation. All right, domain and range. So our domain is the set of all the first numbers, the x values in an ordered pair. Your domain is your x values. Your range is your y values. So if we're looking at functions that are expressed using ordered pairs, tables, or a graph, if I'm going to find the domain, I'm just looking at the x coordinates. So I've got a 3, a 2, a -3, and a 1. All right. If any of those repeat, I only list it once. My range now is going to be an 8, a 7, an 8, and a 5. The 8 repeats, so I only list it once. All right. Now, if I looked at this and I asked myself, is it a function? Well, do any of the x coordinates repeat? No. So it is a function. All right. Is it 1-to-1 or many-to-1? Well, the 3 goes to an 8. 3 is covering 8, and -3 is also covering 8. That means it's a many-to-1 function. All right, our next one, look at your x's. 7, 9, 8, 7, 9. They all repeat, so I only list them once. Then I'm going to list my y coordinates. If they repeat, I only list them once. Okay, is this a function? Well, if the x coordinates repeat, it's not a function. So 7 repeats, 8 repeats, 9 repeats. That thing is a relation, not a function. Okay, now we got our mapping. So we got a 1 that goes to -3 and a 1 that goes to 8. Okay, so right there we know the 1's repeat, so this thing's not going to be a function when we go to graph it. If we were to graph it, it would fail the vertical line test. Okay. So you actually have 2 1's in this. Okay, if we were doing the ordered pairs, this would be 1, -3, 1, 8, okay, 2, 8, and 3, -3. So you can see we've got x coordinates that are repeating. This is not a function. That would be a relation. Okay, our next one, take your x coordinates. So our points on this, we've got a -2, 3. It's that point. Then we've got 1, 2. Then we've got 2, 2. And then we have 3, 3. Okay, so my x coordinates are my domain. All right, nothing repeats there, so this is going to be a function. The y coordinates are 2's or 3's. All right, now is it a many-to-1 or a 1-to-1? Well, if the y coordinates repeat, then it's a many-to-1. Okay, so 1 is covering 2. 2 is also covering 2. So 2 is getting double covered by 1 and 2. And -2 is covering 3, and 3 is covering 3. So this would be a many-to-1 function. All right, now what interval notation is, it's just the way that we write how to represent the domain and the range. All right, so there's these 5 symbols that we use when we're using interval notation. It's just shorthand. We use brackets or parentheses. We use square brackets. We use the infinity symbol, the negative infinity symbol, and union. Union just means when you're putting 2 sets together. Okay, think about like when you get married. Okay, you take all of your stuff and all your spouse's stuff, you move into one place, and you put all your stuff together. You might have doubles of things. That's a union. Okay, when we use brackets or parentheses, we do that when the number is not to be included. So if I wrote this right here, this means every single number is in here from negative infinity all the way up to 4, but it doesn't include 4. 4 is not in this interval. You always put a parenthesis by an infinity sign because you can never reach infinity. So it can never really be included. All right? So 4 is not included in this, and to represent that, we use a parenthesis or a rounded bracket. Square brackets if we want the number included. Okay, so this would be all of the numbers from 3 to 5, negative 3 to 5. So negative 3, negative 2.99999, negative 2.5, all the way up to 4.9999999, and 5. 5 is included here. All right, so here we've got a graph, and this graph goes all the way, it keeps going forever to the left. Now, I didn't draw arrows on these, but that's what you... Okay, now here's one where the graph goes forever to the right. So if we were just doing the domain, remember I worked from left to right. So this graph gets, the x-coordinate gets really close to 0, but it never touches it. So I would have a parenthesis 0, and then this graph is going to keep going and going to the right. So then I would write infinity with a parenthesis. Okay, whoops, that's not 0. I'm sorry, that is 5. So this should be from 5 to infinity. That fire behind me spooked me there. Let's see. All right, so I got a little typo on this, guys. This should be a positive 5. So this is the same as writing x is greater than or equal to, or just greater than 5, or in interval notation, parenthesis, infinity. And again, this is a typo on my part. Okay, this should be a plus. Okay. So we read this, remember this is greater than, not if there was an equal under it, it would be greater than or equal to. So if you lived on this graph, no matter where you lived, your x-coordinate is going to be bigger than 5. All right, so that's going all the way to the left. That one right there. And going all the way to the right. All right, now let's do up and down. All right, so this graph right here, that's an open circle. So that means negative 2, that's the y-coordinate, is not included. And this graph keeps going because of the arrow. All right, so when we list vertically, okay, we go from the x-axis down or from the x-axis up. Okay, so what this means is all of the y coordinates are less than -2. If we did that in interval notation, it would be -∞, comma, 2, parentheses. That means the exact same thing. And looks like I made a lot of typos, guys. I apologize. This should be a -2. -2. -2. Right? Okay, a graph going upward. So this is a solid dot, so we're going to use a bracket. So the y-coordinate of 0 is there, and then the y-coordinate positive infinity. That keeps going up and up and up. Okay, so this would be the same as writing all the y values are greater than or equal to 0. Or bracket 0, infinity. Square bracket 0, infinity. Those are two different ways of saying the same thing. So the next two pages are summaries of if you're naming a domain. Okay, here's the inequality. So remember, when you're reading these, and we always forget them even though we're seniors in high school, read from left to right. That's less. Reading from left to right, that's greater. So this is a table summarizing what we just did. This would be domains, the x's. Here's your inequalities. Here's your interval notation. And here's how you would say these different things using words. And then the next slide is if we were doing the vertical. So all that's changing now is we're using y's instead of x's. So this is the inequality, this is your interval notation, and this is how you would say it in words. Okay, so if you forgot any of this, just refer to these pages, take a screenshot of them if you need to. All right, so here's a function. We want to write the domain and the range. Okay, so there's the line 2x plus 5. It's got a y-intercept of 5, and its slope is 2 up, 1 right. It has a domain from -2 to +2. So what we wouldn't keep drawing this and putting arrows on it, because we only want the graph to go from this x-coordinate to this x-coordinate. So that's why you're only seeing this part of the graph. Okay? And what's been done here is it's called restricting the domain, which is something that you need to understand when we return to inverses. Okay, so that's our domain. Okay, and our range is the highest value and the lowest value. And what you're looking for are these dots or open circles? If they're dots, you're using brackets. Okay, so you notice there it's less than, it's greater than or equal to 1, less than or equal to 9. When we write that in interval notation, okay, it's going to have brackets on it. So this in interval notation would be bracket 1, 9, bracket. And this in interval notation would be -2, 2. Both with brackets because these are solid dots. So that means those numbers are included in the domain and range. Okay, the use of round brackets if the values are not included in the graph, okay, or when the graph is undefined. Okay, undefined means there's an asymptote or there's a hole in the graph. Okay, so if I said, all right, what's the domain and the range? Well, the domain is right and left. Okay, so when we look at this, we can see that our domain goes from, looks like -5 on the left to +4 on the right. Okay, and these, okay, that's kind of hard to read. But you see that little white dot in there? I should have done a better job. These are open circles. It's just hard to tell on the PowerPoint. They almost look like solid dots, but they're actually open circles. That's why we're using the round brackets, not the square ones. And then our range would go from the lowest y value is -4, and the highest y value is 6. All right. Okay, now if we look at our domain, okay, the domain, there's a vertical asymptote, which is your y-axis here. It doesn't touch it. So the smallest x-coordinate is going to be everything down to, but not including 0. So our domain is going to be all the numbers that are greater than 0. That means everything to the right of 0. So that's right there. That's the same as saying x is greater than 0. The range doesn't touch the x-axis here, so our range is from 0 up to infinity, and I'd write that as y is greater than 0. So this notation is the same as x greater than 0. This notation is the same as y greater than 0. Okay, over here, this notation is the same as x is greater than -5 but less than 4. In this one, y is greater than -4 but less than 6. Okay, now I did a little bit better job on these dots. These are solid. Okay, so those numbers are going to be included, so we're using brackets. So there's our domain and there's our range. Range is up and down, domain is right and left. I would write this as x is greater than or equal to -5, less than or equal to 4. Y is greater than or equal to -4, but less than or equal to 6. Those mean the same thing. Okay, we use interval notation because it's less writing than this notation. Okay, it's just less work. Okay, all right. And this one, I think it's got dots on it. Okay, yes. So my x-coordinates here, my domain, so this is a parabola, okay, and it's going to, oh my, that's a terrible line. Okay. That ain't much better. Okay, -3 to 3. That's my domain. And those numbers are included, so I'm going to use my square brackets. Okay, and then my range is going to be from 0. Everything on this graph is, all the y values are greater than 0. Okay, so I'm going to have bracket 0, and then the highest y value, since those are solid dots, is 9. All right, now we've got piecewise functions here. So a piecewise function is just made up, it's exactly what the word is, it just means pieces. Okay, so we call it a piecewise function. All right, what it shows here is if x is between 0 and 1, that's this section right here. It says the y value is equal to 0. Notice it doesn't include x equals 1. When x is equal to 1, now the y value is 10. So no matter where you are on this line, whatever the x value is, your y value is always 10. Okay, and then this section right here, this is the x value. This includes 2 and every number greater than 2. So you notice there's no numbers that are left out. Okay, this thing starts at 0. 1's included, except it's just the graph jumps up to this step. When I get really close to 2, I jump up to this part of the graph, and then I continue to the right. So my domain on this is going to be from 0 all the way to infinity. There are no numbers that are left out of this graph. So that would be 0 to infinity for my domain. All right, now the range. Okay, here's what's happening here. If you're between 0 and 1, your y value is always a 0. If your number is 1 all the way up to 1.99999, your y value is always 10. So you're either a 0 or a 10. Okay, now once you reach 2, your y value is going to go from 20 all the way up and keep going. So then I'm going to write union. I include, let's see, whoops, I made a little mistake here. Right here, yeah, this is 10. Oh, no, we're good. My bad. So 20 is included in this. So my y value is 20 because that's a solid dot, and then that goes to infinity. So that's my range. Okay, all right. All right, school's planning a field trip for freshmen who pass all their exams. The school has 118 freshmen. School bus can hold 54 students. Teachers will ride in their own cars. So here's the equation that tells you how many school buses you need. Well, if there are no students, I don't need a school bus. If I have greater than 0 but less than or equal to 54, I need one bus. As soon as I go over 54 up to 108, I'll need 2 buses. And if I got more than 108 going, then I got to get 3 buses. So if you look at your domain here, okay, when I've got x is 0, and then this is going to be all the numbers that are greater than 0 up to and including 54. And then this line right here represents all the x values that are bigger than 54, but less than or equal to 108. And then this horizontal line is all of the numbers that are bigger than 108, but less than or equal to 118. So if you started down here at the left, okay, I should write it like this. And this first one, guys, should have been x is greater than 0, but less than or equal to 54. And here, this is just x equals 0. All right? So every single number from 0 all the way up to 118 is included in this graph. So that's going to be our domain. All right, now our ranges. Well, 0 is included. If you're on this line, your y-coordinate is always 1 bus. If your x-coordinate is on this line, your y value is always 2. And if your x value ends up on this line, your y value is 3. So the only numbers I have in my range are 1, 0, 1, 2, or 3. Which makes sense. You're either going to use no buses, 1 bus, 2 buses, or 3 buses. Alright, whenever there's a break in the values, that's where you're going to put the union. So when I take my domain on this, if you look at here, I'm doing domain now, so it's x's. So that's 1, 2, 3, 4. This is -4. This is -1. That circle is open, so rounded bracket, -4, that circle is closed. So that's the first part of my domain. Then this is the x-coordinate 1, and that's going to be a bracket. And then this is the x-coordinate 4, and it's a solid dot, so that's a bracket. So my domain is going to be the union of those two intervals. Okay, now my range. Well, the lowest number on here is -2, and it's included. The highest number is a 1, and it's included. So my range is going to go from -2 to 1. Or everything on this one has the same y value, 4. Bracket 4. Okay, and let's see if I think I might have had a typo here. This is solid, so this should be a bracket. Okay, remember this little here, it's hard to see on here, guys, but this is open. This is an open circle. It's got the little white dot in it. It's just kind of hard to see. This is closed, or a solid dot. So our domain is going to include, this x-coordinate here is -8. Okay, this x-coordinate is 1, but it's an open circle, so that's why I got the parenthesis. This is a closed circle, that's why I got the bracket. Then the rest of this, all the x-coordinates on this piece are going to be 3 or greater than. Boy, I had a lot of typos here. Holy cow. Right? Our range on this, okay, the highest value that this ever goes is 6, and then it goes down and it keeps going. So this would be from -infinity to 6. And that's it. So you have Math Excel 3, which is called domain and range, and I'll see you next time.